you guys. Maybe later, maybe another meeting, I can talk about some grouse studies, my grouse studies, because I'm interested in the climate change, and climate change affects birds a lot nowadays, and they change their range. So I have some good results about this, but maybe later we can meet again so I can give more details about these results. Okay, I'm gonna share my screen. Okay, so the first of all, I want to introduce myself. Actually, I started, well, this study is one of my benchmark studies, because I spent almost 10 years to publish these studies. I started this study 2011 when I was a postdoc at AMNH in Department of Ornithology. So I started interested in African biogeography. Before this study, I did a couple of different phylogeographic studies. So I'm interested in DNA and molecular variation in birds. So anyway, I started this study 2011, and interestingly, I never been in Africa to see these birds, but I used all old skin specimens at AMNH collection, and also Field Museum collection, and also Yale Peabody Museum collection, and some specimens came from Europe. And we did actually ancient DNA study. So I tried to be simple to explain all this process, but actually it is it turned out very interesting study. Then we published last year in American Museum Novitates. It's kind of a mini monograph, so more than 60 pages. And we just revised all the classification, and we actually discovered some unique genetic diversity patterns within this group. So this is my actually short story. And I can start right now this Turacos study. As I said, we published this study last year, American Museum Novitates, and well, the George Baraklov was my postdoc advisor, and Jeff Groth, another colleague, and three of us started interest in this group in the beginning of 1910s, 1911 actually. So at that, and then I just tried to get toe pads and some tissue samples from old skin specimens, and try to get the DNA from them. Some of the specimens actually 100 years old, some of them 80 years old, some of them more than 100 years old. And it was really hard to get the DNA from these specimens. It's hard to get the DNA from these specimens, but we did, and we got some success, and well, we actually published. So I'm gonna share right now the results. But first of all, I just try to outline of the presentation. The first, I'm going to talk about phylogeography. The phylogeography means geographic variation of genetic diversity. So I am trying to make a map to understand the geographic variation of genetic diversity within each species. And you will see some different colors that indicates different DNA structure, different genetic diversity, and I'm going to show you later on these slides, and you can easily understand how much variation within this species group. And the first, I try to document phylogeography for this species group, and then we have actually traditional species already described based on the morphological differences, based on some song differences, but we know there are some gene flow not going on between different populations, and for a long time, And I try to demonstrate this, and in the phylogeography section, then we can move to species limit and we can understand how many species we have based on this genetic information. So then I can try to show you the subspecies limits within this group. After I determine this and I move to phylogeny, and I can give you some biogeographic information and phylogenetic information and a big tree, and we can see the relationship between different species, actual different populations, different subspecies, because traditionally we have, I think, 18 different species, but right now we have 32 different species within Turacos in Africa. Okay, so Turacos, actually the green birds, classified under the subfamily Musophaginae. So there are actually 4 different genera: Ruvenzoronis, Gallirex, Musophaga, and Tauraco. So, and there are lots of species within these groups, within these genera. So when we look at the Ruvenzoronis, actually we have only one species based on traditional descriptions, and 2 different subspecies within this species group. And within Gallirex, we have again one species and 2 different subspecies, and subspecies described based on the coloration. One of them here, you can see these brownish breasts. Another one, there is no brownish breast actually. So this is the main difference between different subspecies in this group. And then another group, Musophaga, this group looks like completely different kind of Turacos. So we have two different species, and this is the monotypic species. There is no subspecies in this group. And then the other group, other genera, Tauraco, and we have lots of variation within this group based on the head patterns. And if you look at the head patterns, you can see lots of differences. For example, this is the Tauraco persa. The main difference between these 2 subspecies, one of them has white line under the eye, and another one has the black line under the eye. So another interesting group, Tauraco hartlobi, these species actually use small range. I will show you some interesting results about this group, about this species later on. So this is monotypic species, but there are lots of genetic diversity within this species. So another group, shallow eye, there are some mountain endemics, different subspecies, endemic to mountain tops, and there is no gene flow between other populations, and there are lots of variation also within this species, but we have only see the 2 different subspecies. Again, the main difference is the black line under the eye and white line under the eye. So, but it's handsome birds. So as you can see, there are lots of variation based on the head patterns in Tauraco genus. So this is all Turacos, all green Turacos, and this group actually endemic to sub-Saharan Africa. But as I said before, I focused on the only the museum specimens, old specimens, and most of them came from AMNH collection, American Museum collection. But I also visited Yale Peabody Museum, Field Museum, and I tried to get some more sampling from them, because Field Museum has very good collection from Africa. Yale Peabody Museum has very good collection from Africa. So we took this advantage. And the sampling size for this study, over 400 samples, and 95% of them based on the skins. So I try to cut small toe pads from here and try to get the DNA from these dried specimens. It was really hard, but but worth doing it because we got very interesting results. So we have, this is the distribution range for the all Turacos. As you can see, they are, well, actually they are endemic to sub-Saharan Africa. There is no Turacos north part of the Africa, so they all distributed sub-Saharan Africa. So we covered almost all distribution range. We have 91 sampling locations. So we have some good sampling from some locations. The diameter of the circles indicates the sample size. So we have some good samples, we have some poor samples, but the main problem is the Congo, middle of the Congo. We don't have any samples based on the historical skin specimens, because the middle of the Congo is a very dangerous place, and probably every 2 weeks the borderline always change, and it is very dangerous place and nobody goes there, and there is no sampling actual middle of the Congo, but we have other places and we have enough sample size from other spaces, other places, and we have 91 sampling locations. We covered almost all distribution range of Turacos. So, okay. As you can see here, there are lots of different colors. So this is the haplotype network. So we focused on the mitochondrial DNA first. Mitochondrial DNA has some advantage because mitochondrial DNA accumulates lots of mutations. So this is the small organelle in the cell. So, and accumulate lots of mutations, and we try to get one of the gene, mitochondrial DNA gene, and try to understand how many mutations that we have, and within each species, each Turaco species, and we got this diagram. And as you can see here, between the groups, there are lots of mutations. Every single dot shows the mutations, and there are lots of mutations between different groups. And each circle here has the different colors that indicates different DNA structure, different mutations and different DNA structure. And when we look at the Turacos, we can see lots of genetic diversity going on in this group. There are lots of genetic diversity. And one group, actually this group, Tauraco persa superspecies complex. So I showed in the previous slides, I showed the different head patterns in the green Turacos. They're all classified, they're all located that area. And there are lots of different colors, there are lots of different DNAs here. And we found really interesting genetic diversity patterns within this group. So I'm going to show you some interesting results. For example, this group, this species, Tauraco shuetai, and the main difference between these two groups here, the purple back and the green back. One of them nominates Tauraco shuetai, another one Tauraco shuetai emini, and traditionally this species accept the one species, and only the difference between them, these color differences, and the ornithologists, well, based on the traditional observation, they decided there are different subspecies within one species. But when we look at this group on the haplotype network, the emini, one of the subspecies which has the purple back, really far away from, where's shuetai here, the shuetai, and based on mitochondrial DNA, the divergence rate between these subspecies 2.7, which means almost, well, almost 1 million years, they never come back, they never come together and breed, and probably they diverged 1 million year ago based on this mutation rate, and probably they have to be classified as different species because they don't breed together based on the empty DNA results. This is one of the interesting results within this group. So another one, Tauraco macrorhynchus. Based on the results, we changed some genus name, some genera names, and also we changed some species names. You can see actually the new species name here, but I'm going to show you later. So this is the another white separate bird species in west part of Africa. The main difference between this group, there are two different subspecies again. One of them has black line upper head, and one of them the red line, the upper head. This is actually the main difference between these two subspecies. But when you look at the DNA, they are sister species group, and the divergence rate again high. And when we look at the same group, when we look at the map, one subspecies distributes in the west part of the Africa. This is the one of the barrier I will show you later. And another subspecies distributes here. There is an allopathic barrier, geographic barrier between these two subspecies. And head's pattern is different between these two subspecies, and also DNA is different between those two subspecies. And we recognize actually we have two different species within this species. So one of them distributes in the east of the west part of Africa, one of them distributes the west part of Africa, and this area actually very good geographical barrier and has completely different habitat structure. So another group, Musophagidae rosi, I mentioned is a different. It's not their coloration not like the green Turacos or other Turacos, completely different. So, but when you look at this group, there is no subspecies, and there is not much variation within this group. So all the DNA from north to south, almost one or two different mutations, the characterize one or two different mutations, and there is nothing going on within this species. Probably after the glacial periods, this species colonize their distribution very fast, and there is not much variation within the distribution range of this species. And another Turaco, Musophagidae violacea, the violacea between, for example, between this location to this location, more than 3,000 kilometers. And when we look at these 3,000 kilometers, there is not much variation again based on the DNA. So again, there is no subspecies, and there is not much variation within also Musophagidae violacea, this species. And another interesting results for these two groups, we have find lots of variation within one of the Turaco, but the other purple Turacos, we don't have actually enough variation to describe the different population or different genetic diversity. So again, I want to show you the yellow-billed Tauraco, and I want to show you this Dahomey gap. The Dahomey gap is very important biogeographic barrier for Western Africa. So this area and also this area has some forests, rainforests, but this area, Dahomey gap, no forest, actually completely different habitat structure and very important for the birds of Africa, diversification, for the diversification pattern for the birds of the Africa. Okay, so let's move on another group, Tauraco hartlobi. Maybe you remember when I showed the green Turacos, I told you there is one Tauraco have very small range but lots of variation within small range. This is Tauraco hartlobi. There is no subspecies within this group. Very interesting bird group. This group actually uses the mountain tops. So like a cloud forests, there are lots of allopathic population in Kenya, but there's their range is very, very small when we compare the other Turacos. For example, Musophagidae, for example, Tauraco macrorhynchus, yellow-billed Turaco, there's very small range. But let's see what's going on in this range. So this is the distribution range. This Tauraco hartlobes Turaco distributes in this area in Kenya and Tanzania and small part of Uganda. It's very, very tiny distribution range. But when we get the sample size from Kilimanjaro, from Usambara Mountains, from Elgon Mountains, and when we look at the mtDNA variation, we have this pattern. We have this kind of variation. There are lots of variation going on within distribution range. Again, each color shows us different DNA structure, different mutations, different DNA structure. And Usambara completely different than Kilimanjaro. Kilimanjaro and Usambara completely different than central part of the Kenya population. And Elgon actually completely different than others. And Niiro and Kulal populations also different than Elgon and the other populations. So, but when we look at the birds based on the coloration, there is no variation. The Elgon Mountains population completely similar to Kilimanjaro population. So there is not much variation going on based on the morphology and coloration. But when we got these DNA structures, DNA data, and when we have the tree or haplotype network, we have this. And the Elgon Mountain population sister to other groups. And this population probably different species and Tauraco hartlobi complex, in Tauraco hartlobi complex, there is some cryptic diversity going on. Probably this group is kind of a cryptic species complex. So we have no morphological variation, but different species within this group. So we have very good evidence about this, and we try to get some different DNA elements like nuclear DNA instead of mitochondrial DNA, but we have not many fresh tissues. We only focused on the ancient DNA. We couldn't get enough success to determine this group is the different species, but we have very good sign. This population probably the different species, and Tauraco hartlobi is a cryptic species complex, but we probably describe later on because of the COVID-19 process. I couldn't go to the United States. I'm still waiting. So when we get vaccination, so probably I can go back and work on this group. So I showed you some examples, but when we look at the haplotype network, complete network, there are lots of variation going on for each species. I'm not going to show you each species, but you can easily understand lots of genetic diversity located within Turacos species complex, and we determined the species limits based on this methodology. Then we try to get the phylogeny based on this information. So this is the phylogeny, and ND2 here, mtDNA data, and aconitase nuclear DNA data. These two genes completely different. ND2 evolves faster than aconitase, But because of this situation, we have very good resolution in ND2, mitochondrial DNA, but we don't have the very good resolution for aconitase because aconitase has slow evolutionary rate. But still, we have very good concordance between two different genes. There are some mismatches, like great blue Turaco, based on aconitase, great blue Turaco sister to go away birds. But based on mitochondrial DNA, great blue Turaco sister to other green Turacos. So this is one mismatch, but another three mismatch for Musophaga rosy, for Tauraco donaldsoni. So we changed the genus name Melanicornis because this is the old one, and this is really diagnosable than the others. So we prefer to change the genus name. And another one is Turacos. There are three mismatches, but other than that, these two gene tree completely concordant. So it's a good sign for us for the clear classification. Then we also try to get some exons, another slow rate gene located in the nucleus in the cell. So, but for this, we only use the fresh tissues. Most of the samples came from the skin specimens, 95% skin specimens, but we have some fresh tissues and we try to get some reg1, the exon data. And then we combined everything together, aconitase, ND2, mitochondrial DNA, intron aconitase, which is aconitase, and reg1. And then we try to get the complete species tree. And we have this. When we get this, based on the fresh tissue samples, again, the results completely concordant with the other genes, but the great blue Turaco sister to go away birds again. So probably great blue Turaco sister to go away birds, but the other Turacos has different biogeographic or evolutionary stories. So again, the Musophaga, rosy, violacea, and Tauraco macrorhynchus actually cluster together, and we prefer to use Musophaga as a genus name for all this group. Musophaga macrorhynchus. For yellow-billed Turaco, we changed the genus name from Tauraco to Musophaga. So again, we have all these green Turacos here, and this is almost concordant with the gene trees. So, and then we actually get to some conclusion, and traditionally we have 18 different species within green Turacos, but the species numbers have changed after this study, and this is actually the conclusion. So we have, within Turacos, we have some heterogeneous population structure across the recognized species. We found some large and small scale differentiation. As I showed you for Tauraco heart lobi, it's the small scale differentiation, one of the examples for the small scale differentiation. Also, we have some large scale differentiation, and we allocated 33 different species to 7 previously recognized genera, and average of 4.7 species per genus. And 3 different genes provide well-supported phylogeny for these Turacos. So actually, this is very important bird group. Nobody knows much about this. So far, I think Morrow, who is British ornithologist, published a big monograph in 1960s in IBIS, in British Ornithologists Union publication. So after that, Veron and his colleague published another phylogenetic study based on the zoo specimens, and they don't know the location names, and based on these specimens, they published a phylogeny, mtDNA phylogeny, but not complete. Then we did this study and we cover all the subspecies, actually we cover really all the subspecies and all the species. There is nothing left. And we got this phylogeny for this group, and we found some hidden genetic diversity in Africa. So we believe it is very important for the African biodiversity and biogeography. So this is actually the first step. I really want to continue with this group, actually the go-away birds, another interesting bird group, and we want to do some phylogeographic studies for go-away birds. Actually, we planned to start last year, but because of this COVID-19 process, we couldn't do that. And yep, that's all I can say right now for Turacos. They're enigmatic bird group, and it's very, very nice, very handsome bird group. So thank you very much for your patience. And if you have any questions, I'm open to questions. So thanks a lot.
Hey, thank you, Utku. So I have a few questions that came to my mind during the talk, and then
of course,
I'll kick off by asking a couple of my questions. Anyone else in the audience, if you have a question, please post it in the Zoom chat window. And as those questions come up, I will read them, and Professor Perktas can give us his answers. So I wanted to start off, and you kind of touched on this topic a bit during the talk, but you mentioned the difficulty in getting kind of fresh samples of DNA to work with, as opposed to the museum skin samples. Can you contrast a bit sort of the reliability of results, or the types of results you tend to get from kind of older versus newer museum specimens, and then from fresh field tissue results as well?
Actually, based on the mutation rate, there is not much variation, because within 100 years or within 80 years, we don't expect any mutation accumulated actually in the DNA. So the reliability of the study is really high. But the problem is, if we have fresh tissue samples, probably this study can finish faster than this study. Well, the new study probably, if we use the fresh tissues, probably we can finish this study faster, quick periods. So the only problem, I try to cover all the distribution range. Actually, I used more than 400 specimens, but I try to use maybe 600 or 650 specimens, and 250 specimens never work because of the condition of the DNA. So because, for example, Chapin collected most of the specimens at AMNH in Africa, and probably he used some chemicals to protect the skin specimens, and he damaged the DNA. So then I couldn't get the clear DNA sequences from that specimens, and I just reached the almost more than 400 specimens, but not 500 specimens. But I tried to use maybe 650 different specimens. So the only problem is that, but other than that, the reliability of the DNA data is fine. So we don't expect any difference within 100 years.
Well, and your ability to extract the DNA from the specimens doesn't change with the age of specimens, but only with the techniques used to preserve them then?
Right, yeah, definitely, that's correct.
Okay, interesting. So let's see. I saw when you showed the map of the Tauraco family in Africa, it looked like there was sort of a very large area that was fairly continuous, but then there was a kind of a disjunct section to the northeast, and sort of like the Sudan, Ethiopia area.
Ethiopia has another different green Turacos. So Tauraco, well, actually, we changed again the genus name Melanicornis. So there are 3 different species, one complex breeds over there. One of them endangered species for Africa, Tauraco, well, Prince Turacos, so Tauraco ruspoli. Actually, this species occurs one of the mountaintop. So well, it uses a very tiny distribution range. So it's endangered. And another 2 species, Tauraco, not Leico, well, I think Leicolophus, and white-cheeked Turaco. The common name is white-cheeked Turaco. So it uses another small distribution range in Ethiopian mountain area. So, well, one populations looks like a disjunct populations to other Turacos. That's correct.
Okay, and so within the Ethiopian range, all the species found there are each other's closest relatives. Is that a single clade?
Right. Yeah, definitely.
Okay, there are no other clades that cross over that divide.
Actually, I can show you just a second. It's gonna be more clear. Yeah, the Leucotis, Donaldsonii, and Ruspoli here. This is the Ethiopian Turacos, this group.
Okay, interesting.
Yeah.
Okay, thank you for illustrating
well,
that.
I thank you.
All right. Let's see. You mentioned in West Africa I believe you called it the Dahomey Gap.
Right.
And that there were bird species on either side of this gap and that weren't present in the middle. What is the habitat difference? What sort of habitat is in the gap that's not suitable for the birds on either side?
The gap has like a savanna habitat. There is no trees.
A savanna, grassland.
Yeah, the grassland savanna, but the west part and east part of the gap has rainforests. So this is really good barrier, and there are lots of different kind of diversification patterns for different bird groups. Not only the Turacos, but also the other bird groups show different kind of diversification rates because of this Dahomey gap.
Okay, and there was like historically, sort of prehistorically, was it rainforest all along there, and then the gap formed, dividing it, or?
Right, that's true. Historically, actually, the rainforest looks like continuous, but because of the Dahomey gap, because of some biogeographic stories, Dahomey gap just appeared, then the diversification patterns showed up for the different bird groups.
Excellent. I think we have some examples, some kind of similar examples that have come up in this country with a few bird
right.
clades. I guess you may have studied a few of those. You've done a fair amount of research here, but okay. We have let's see. Next question. In light of kind of the human events in Africa, the sort of political uproar you mentioned in the Congo, and climate change, the pandemic, everything else that's going on kind of from the anthropogenic end of things in Africa, how thoroughly are people able to monitor the various species of Turacos there, and how well do we know, for instance, if any of the species may have gone extinct? Are they all still extant, or changes like that from time to time?
It's a very good question, because Turacos usually use, the green Turacos usually use the canopy of the rainforest area. So, and it is really hard to follow them. So actually, there are some observation in eBirds So I try to use to understand the climate change effect on this bird group. But there are not many observations for Turacos because it's hard to see them. So they always use the canopy of the rainforests, and because of these political problems, so probably bird watchers in Tanzania and Kenya have good observation records, but for Congo, we don't have enough observation records. The only observation records came from the museum specimens that historically collected based on the Field Museum, AMNH, or Yale Peabody Museum, or some other museum in United States and Europe. So other than that, we don't have enough information right now, and we don't know what's happening for Turacos in Africa. So, but I am right now working on these climate change effect on Turacos based on these observation records. So the climate change is going to affect this rainforest area, and of course, it's going to affect the Turacos and other bird groups. So yeah, this is only I can say right now for this question.
Yeah, the sort of a related question to the you're mentioning the Congo situation and the sort of lack
Right.
of data on the birds from there.
That's true.
Is there information on the habitat in the Congo that might enable you to speculate on what you would expect to find if you could get DNA from the birds there?
Oh, actually, yeah. Middle of the Congo, I think there are lots of going on. I think if we can get fresh tissue samples of from middle of Congo for example, Tauraco shuetai, probably we can find very good evidence to understand the geographic barrier between west and east part of the Congo, because there are something going on middle of the Congo and we don't know. That's why I just try to use the all available observation records to understand, is there any climatic barrier between west side and east side of the Congo, because we only know there is only one barrier. The Congo River is a big river, and it's a good barrier for not only for birds but also for other vertebrate species. So, but I think there are something going on based on the climate. So I try to understand some climatic barrier. But if we get more fresh tissues, probably we can easily understand what's going on. This is my hypothesis right now, based on this information, based on this study.
Okay, so this river, the Congo River, you think would present a significant barrier to gene flow from one side of the river to the other?
Right. Yeah. This is definite. This is certain. But also not only the Congo River, but also some climatic issues between west and east part of the Congo also affect the diversification patterns for birds, probably for mammals.
Mm-hmm. And I think during Lucas Musher's talk a couple of months ago, he mentioned that many of the Amazonian forest birds were very reluctant to cross open spaces and typically remained very tightly within the forest. And if there was, for instance, deforestation that caused fragmentation of the habitat, they would remain in their fragments and not travel from one to the other. Is that
right.
the case with the Turacos as well?
Yes, definitely. Yes, that's true for the rainforest areas. Yeah, definitely.
Okay. Let me see. I think there's at least one more question. Okay, and was one more question here, and then anyone who has a question they haven't asked yet can make sure you throw it in while Professor Perktas is answering this one. So, but you mentioned, so it's very difficult to see the Turacos in the habitat because they stay up in the canopy a great deal. And even upon seeing them, some of them are visually very similar to each other. What about vocalizations? How easy is it to distinguish them by call and
Right.
or
So
to detect them by call and to tell
yeah,
species apart by call.
for some Turacos, I think, well, actually, one of my projects that I applied to go to the Kenya and record this Hartlobi song from different populations, because we found significant diversification, mtDNA diversification within each mountain areas. But we couldn't get enough budgets to do that. And then I used Xenocanto song data to understand the diversification. There are something again going on, but we don't have enough evidence based on the song information. So we have to go there and just record the actual songs and to understand, is there any difference. If we find this, probably we can definitely suggest different species within this group. But also the other Turacos, I think there are some small differences. Again, based on the Xenoconda database, we heard and we try to make a sonograms and try to make some calculation between different sonograms. We saw some small differences between subspecies, but between species there are lots of differences, of course. But between subspecies, we saw some small differences, but I don't know whether it is enough to suggest something or not based on the song data. But there are some variation going on, definitely.
Excellent. Okay, and I'll mention, not everyone in the audience may be familiar with Xenocanto. I guess maybe I'll let you, if you want to explain, Utku, what Xenocanto is for people who haven't, who maybe are, less versed in internet ornithology.
Well, the Xenocanto is again like an eBird platform. So people usually record bird songs and upload the Xenocanto, and you can just download this data from all of the world. You can download some data from Turkey, from birds of Turkey, and you can download some song data from North America or somewhere in Asia. So there are lots of bird watchers record bird songs and upload this platform. It's kind of an eBird, so it's kind of a different observation record. So, and it's very useful, and you can hear different kind of songs for each bird, and also you can make a sonograms and you can make some comparison if the data has enough quality. So yeah, it is kind of eBird platform. So xenocanto.com, I think the web address. So it is very useful.
Yeah, that sounds about right. So yeah, I know certainly for here in the US, Xenocanto has very large libraries of the vocalization of different bird species, and in Europe also. So hopefully Africa will get enough traffic and people with recording equipment to be able to fill out that. Okay, I think that brings us to the end of the questions we have here. So we'll say thank you for the program, Utku. And one negative I always cite with Zoom as we do these talks is that if you were here in person, we could all stand up and give you a round of applause. And since it's only on our computer screens, you'll have to mostly imagine that.
Well, thank you very much for everyone. So thank you very much for this invitation. So it was really great